Hey guys, welcome to another math note. So I'm going to start this one just slightly different. I want to share with you something I was reading in the news. If you guys don't know, there's a YouTuber named Logan Paul. Logan Paul made a lot of money with his YouTube videos, and he spent some of his money by getting Mercedes-Benz couches that originally cost $90,000. Right now, he is trying to sell them for only $20,000. So if you have, $20,000 laying around in your bank account, you can get his Mercedes-Benz couches that were originally $90,000. A great deal. It's only 22% of the original asking price. But really, my word of advice to you is if you get crazy rich, like Logan Paul, I don't know, use your money towards getting something better than only two couches for $90,000. I don't know, maybe an amazing car instead. All right. I'll stop with my rant. Today we're going to do another display of values. It's called, we're talking about quartiles and box plots. Box and whisker plots is how they're also known. So we're going to do a quick couple of definitions and then answer some questions. So the lower extreme is called the smallest value. So we'll write that in there. The smallest value is also your minimum. Your upper extreme is the largest value. Which is your maximum. And we use these values when we calculated range, so quick reminder on that. There's something called the lower quartile. This is the median of the first half of values. Also known as Q sub 1. Upper quartile. This is the median of the second half of values. Also known as quartile 3, third quartile, Q3. Oh man, I'm cut off. There you go. Sorry about that. Interquartile range. This is your third quartile minus your first quartile. So basically, it is known as the range between quartiles. So the range between quartiles. We're going to use this information to create something called box plots or box and whisker plots. Okay, so what we do is we divide data up roughly into quarters by finding the quartiles of the data set. So shown below are the scores of 16 students and what they received on a math quiz. I already have them in order for you, least to greatest. The first thing that we're going to do is we're going to find the mean. The mean is also known as, so AKA Q2, your second quartile. And with 16, the halfway is going to have 8 on each side. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's where I'm at. So the median is going to be right here. Remember, all you do is you add them together, divide by 2. And so I know that when I do that, I'm going to get 73.5. But real quick, when you are doing it on your own, this right here is the math to get there. Part B is asking for the range. So range is from your maximum minus your minimum. So 98 minus 52, and that gives us 46. Box in my answers here real quick. Next, what we're going to do is it says find the first quartile. So the first quartile is the median of the lower half of the data. So the lower half of the data ranges from 52 to 73. So that was 8. And so halfway between 8 is 4. So 1, 2, 3, 4. I'm right here. This right here is going to be my Q1, first quartile. And same thing, we add them together and divide by 2, and that's 67. So Part D, find the third quartile, same thing, halfway between 8 is 4, 1, 2, 3, 4. And again, if I had an exact, like let's say I had 5, then with an odd number, I have an exact middle number, and I'm going to use that exact middle number. In this case, I have even. So anytime we have an even set of numbers, we add them together and divide by 2. So 82 plus 84 divided by 2 is 83. So now we're going to take this information and create our box plot. So the first and third quartiles are also known as lower and upper quartiles, which we have in our definitions up above. The quartiles, the median, lowest, and highest values in the data set comprise what is known as a 5-number summary. So 5-number summary is an important definition to know. So I will be referring to this quite often. Okay, the 5-number summary is this right here. So we're going to use the same data from up above, construct the box plot. So the minimum is my smallest value, that's 52. And again, I'm just using the data from up above. The quartile 1, we found to be 67. The median is 73.5. Q3 is 83. And your maximum, your highest value is 98. So again, all of this right here is important. This is my 5-number summary. Okay, so remember that when I refer to it. All right, and then let's go ahead and create that. My smallest value is 52, highest is 98. So my range should go from 50 to 100. And I think if I just go by 5s, I can fit it all on here. So 50, 55, 60, 65, 70, 75, 80, 85. I got 90 and 100. Okay, so creating that number line. My minimum is 52, so I'm going to mark that point. It's right about there. Then 67, right about there. 73.5, right about there. 83, and then 98. Okay. What I'm going to do is create my box in the middle. So I'm putting lines where I have my dots, and then the whiskers is this right here. All right, that's it. So remember, this is my minimum. This is Q1. My median, which is also Q2, quartile 3, quartile 4, which again is also my maximum. What this has shown is the way that I divide up all of the data into fourths. So 1/4, 1/4, 1/4, 1/4. Other ways to think about it, my middle half, okay? And we can convert this to percents as well. So 25, 25, 25, 25%. You know, I have my middle 50%, and that sort of thing. Next, interquartile range. Interquartile range is Q3 minus Q1. So the middle set of my numbers in that range. And so that's going to be 83 minus 67, and that's 16. Okay. What does the IQR represent in a box plot? This is the spread of the middle 50% of the data values. Let's write that down. The spread of the middle 50% of the data values. Okay. And let's go ahead, once you have that copied down. Did you guys get that all? I'm sorry if it was, you couldn't see quite a bit of it if it was cut off, so I'm sorry. On the back, I just have a couple of quick questions. Here we go. that pertain to these two box plots, which is going to be probably a little bit more of what you see on your Google form. So what is the median of each data set? So we're going to find A and B. So for A, it is 70, and for B, it's the same thing. Okay, median is right in the middle. Which plot has a lesser range? So it's going to be A. A has a lesser range because my box plot is not as spread out. It's a little more condensed. Which plot has a greater interquartile range? Well, that's going to be where it's spread out more, and that's going to be box plot B. What is the upper quartile of each box? Okay, so upper quartile, that is going to be Q3. So for A, it is 80. For B, it looks like it's 85. Then the lower extreme of each set. So same thing, this is going to be Q1. So for A, it looks like it's about, oh, I'm sorry, lower extreme. So this is my min. Yikes. It's 50. For B, it's 40. 6, what percent of the data in plot B is between 60 and 85? Okay, so I'm looking at plot B, this one, between 60 and 85. That is 50% of my data. Okay. 7, what percent of the data in plot A is greater than 80? So looking greater than 80, that is just 25%. So Q3 to Q4, 25% of my data. What percent of the data in plot B is less than 85? So here, 85, that's 25, 25, 25 for a total of 75%. Okay? All right, that's it for these notes. Again, email if you have any questions or concerns. Stay healthy, stay well, and take care of yourselves. Talk to you guys later. Bye.